We're really excited to be here.
First time in Pittsburgh.
First time in Pittsburgh for both of us. Thank you. Look like a lovely town.
It does.
Yep. And yeah, thank you for coming and staying late instead of going home. We will try to make your time worthwhile.
We strive to entertain.
Yes, that's what we do, right? And today we're going to talk about DevOps at scale, and we're going to talk about DevOps at scale as a Greek tragedy for a very simple reason.
More often than not, the results.
You know what's interesting about Greek tragedy?
Anybody? We had one person who did know.
Yeah.
Every time we asked, but
anyone?
So the funny thing about Greek tragedy is everybody has to die at the end.
And obviously that's why DevOps at scale is a Greek tragedy, right? We'll start with a little introduction, prologue, if you wish. And this is us, already introduced by Mike. My name is Baruch Sadogursky. I'm developer advocate at JFrog. And Baruch over the internet.
And I'm Leonid Igolnik. I'm on a sabbatical right now, an executive with companies like Oracle, Taleo, CA, running operations and development for several of our SaaS products.
Right. And so we see DevOps at scale from different perspectives. JFrog, we develop tools for making DevOps more successful, and you might heard and you might use one of them or more than one. Artifactory is the most known one who uses Artifactory here.
Who uses Artifactory here and doesn't know that they use Artifactory?
Probably most of the people, right?
You see?
Yeah, no, so yeah, if you are with BNYML and you use Artifactory, I have news for you. So we see it from the perspective of the vendor, right? So we see the problems that our customers and users encounter and try to help overcome the obstacles.
And I'll talk about the perspective of the practitioner, having run engineering and development and operations for some of the largest SaaS products at the time, 5-6 years ago. We've certainly run into a lot of those challenges and went through a lot of the stages that we're going to be talking about.
Right, I'm trying to see, do you see the red light there? The recording? Okay, good, just wanted to make sure. Because, yeah, and the recording is important because of this. So later tonight, when I'm back in our hotel room, I'm going to prepare a special page for you, JFrog.com/show notes. You will go there and will find all the slides, the video, right? Hopefully I will edit it later tonight and the internet will allow us to upload it by tomorrow. All the links to all the stuff that we'll mention, including some terms in Greece, how to say it?
Methodology?
Yeah, it's not methodology.
Literature.
It's like, yeah, it's more like a theater, right? And a small raffle as a token of appreciation for you being here, something small and nice for just coming to this page.
All right.
So with that,
let us begin.
Let us begin. And our talk obviously should start with the question, what the hell is DevOps? And
well, Greeks loved Venn diagrams.
Yeah, they have a soft spot for Venn diagrams, as archaeologists discovered. So we will explain DevOps in Venn diagrams.
At least two of them.
Right. And the first one is obvious, right? So you know by the name, you take the dev, you take the ops, you kind of mix them together, and you.
They clearly forgot to invite QA when they created the name. Yeah.
Right. So you get all this, and then later they added QA and decided not to change the name because it's kind of weird.
It just doesn't sound well. Dev QOp, QDev. Yeah.
Doesn't. So yeah. So this is DevOps, and this is kind of the canonical thing that you all know.
But in today's talk, we're going to take a slightly different perspective on DevOps, and we're going to look at it as an intersection of people, technology, and tools.
Right. And that intersection gives DevOps as well. I'm trying to recall what did I forget during the introduction, and I recall the t-shirts.
Yes.
Right. So except of doing awesome software, we also make awesome t-shirts. I have some of them over back. It's not a lot. If you plan to come tomorrow for our second session of this 2 days meetup, I will have more. If you don't, try to get one today while they last. Sorry, back to the topics.
So our tragedy begins with a mythical company, Pentagon Inc.
Well, and there are a lot of puns intended here. First of all, they are a company named after a geometrical shape that does credit card processing. I don't know.
So happened, slightly different shape than maybe a competitor.
Rings any bell.
Yeah, happened to be a Greek word as well. So
yeah. And there is another one coming down the road.
You'll see why. So let's start. Act 1. Our first act is called Fire Brigade, or Reactive Operations.
What does it mean?
What does it mean? So, let us see.
Before we start with an action, we would like to set up the stage, as it should be in theater. And as you remember, people, process, tools. Let's start with people.
Well, it's a small startup. They just started, just 3 developers, right? They quit their corporate jobs and they decided to start a company, so there's just 3 of them. They happen to be based in Washington, D.C., came from on-premise software background.
Another company, Pentagon.
Wonder why, may have worked in defense, did some interesting work there. They're pretty smart. They're good software engineers. They understand the best practices. They understand what good looks like.
They're a little bit of hipsterish.
You know, they felt the freedom of leaving the corporate environment, so they wanted to use all the latest technologies.
So they do JavaScript, Node.js, Reactive, microservices, basically all the buzzwords.
All the buzzwords. Well, we're missing serverless and Lambda.
It's not here. Serverless is in the next slide.
So, well, what kind of process a company of 3 people has? Not a lot, and that's what's appropriate, right? The dev process is pretty simple, Kanban. Maybe they use a tool, maybe they use Trello, maybe they use stickies on the whiteboard. There are just 3 of them.
As we mentioned, they know their technology, so they do proper QA in terms of test-driven development and all the possible tests.
And all the layers,
integration,
right?
Everything is automated, good code coverage. They feel pretty safe about the code that they write. Yeah, so Ops, they went to some conferences like New York, and they learned a couple of buzzwords, and a couple of them they liked a lot.
Yeah, the cool one is no ops.
Serverless is very cool as well. Serverless means we don't need to take care of any servers. And remember, they came from on-prem development. They are not the ops guys. So when they heard serverless, they're like,
yay!
They can do anything. And the other, which is even better, is no ops. Right, this is what we do. We don't do ops, so no ops.
Like, who needs them, right? Easy start.
All right. So their toolchain looks very minimalistic, right? They have Jira or GitHub issues or Trello or any other tool for managing backlog and tasks.
Yep.
Right. They use GitHub or Bitbucket or any other cloud-based
source
control. Travis CI, heard about Travis CI? Anyone?
Yeah, a few folks.
Okay, good. So, who heard about Jenkins? Everyone. Okay, good. So, Travis CI, think about it as a CI server in the cloud as a service, right? Kind of Jenkins, but runs in the cloud. Very minimalistic, connects to GitHub, pulls the sources, builds them according to what finds in the sources, plus very minimalistic instructions, and then deploy it.
They went very simple. No ops.
To the cloud.
They just went to a PaaS, platform as a service. In their case, they chose AWS Beanstalk. You know, it's magical. You put the code there, it auto scales, auto deploys.
It just runs. It can be, of course, Google App Engine. It can be
Oracle's cloud
thing.
Variety of things.
Any cloud can work, right?
And the software, they're just getting started. The product is not very, very heavy yet.
So this looks like a solid start for a three people company.
What could go wrong?
I mean, yeah, seriously.
Well, like any startup, they work for a long, long time building the first version of the software. That takes a while.
And then they wait.
And then they wait.
They wait for the first customer. They do some legwork around Silicon Valley and try to find someone who will be interested in their great software. And eventually, they
find one.
Yep.
So what does a good startup do when they find their first customer? Naturally, they drink.
They do, right? It's a pretty big customer, right?
It's some internet celebrity, something Ardashian, something.
Starts with car and
chosen them to power the online properties.
yeah. So whatever they have on their sell on their Instagram, this is how.
Yeah. So they celebrate on Thursday.
Things they celebrate all the way through Monday.
Yeah.
Monday and then they kind of go home Monday late night, and then
They get the call.
customer calls.
Nothing works. But don't despair, you know?
No, this is terrifying because remember, this is kind of the first day they run in production with
Yeah, that's
customer.
right. What do you do first? You panic.
You panic, obviously, because this is scary. And they're all like completely unconscious after the party they just had.
And then what do you do?
But
you charge.
Yeah, but somehow they get themselves together and try to solve the problem.
Well, listen, the good news is we have no ops. So I got the root, you got root, he has root. Let's go online and see what's going on.
Right. So we try to find, let's look at the logs.
Wait, where are the logs?
It's serverless. That we don't have servers, so I'm not sure where the logs of the non-existing servers are.
Oh, there's this thing in AWS Cloud Console. There's like 1 log, 2 log. We have 15
Yeah,
microservices.
that's microservices. That's a lot of logs.
Okay, so let's try to figure out how to look through all of them.
Yeah, so here there is a clear exception that happened at 1 a.m. in the morning.
Wait, mine is at 3.
So is it the same exception?
I don't know. What time zone are you in?
I'm on US East. What's
Oh,
you in?
we're in somewhere else. Anybody had to do time zone acrobatics in the logs before?
Yeah.
Sounds familiar?
All right.
What else could wrong? Well,
So eventually they found the exception, and it turns out that one of them, the very nice guy called Billy,
Billy, after the party, went home and had a brilliant idea.
of course, because they drank for 2 days in a row, obviously, tons of great ideas. And
So he committed something.
as you remember, right, you write the code, you commit, it goes to Travis, it goes to production. This is how it works.
Continuous delivery. Right, so no despair. We're going to roll back.
Yeah, so that's easy. All we need to do is find the commit before that and build it, and everything will be.
Let me try. Wait. It doesn't build.
That cannot be. We just build it couple
No,
times ago
it's
and
missing a
it's
dependency. I don't know what's going on.
Well, who remembers NPM gate?
About a year and a half ago.
Anyone?
No? 12 lines that broke, 12 line of JavaScript that broke the internet. Yeah?
Look at that. Right? 11 lines.
11 lines.
11 lines.
There must have been an empty line at the end.
Yeah, or a comment. Well, yeah, so it's a fabulous story. It's actually from March last year. JavaScript, they have this package manager called NPM. And they discovered package management some time ago, a couple of years ago, and got pretty much excited about it.
So there are a lot of packages.
There is a lot of packages for everything. Now, left pad, and that's the tool. It's 11 lines of JavaScript code that does exactly what the name implies. It pads the text from the left. Apparently, in JavaScript, you need a package.
I'm sure there's a right pad as well.
Right, and probably there is a right pad as well. So anyhow, the author of left pad got into some beef with the NPM registry.
Got upset.
And got upset and took his stuff and walked away. He unpublished all the modules that he published, including LeftPad. And
apparently, half of the internet depended on LeftPad indirectly. Or directly, mostly indirectly.
Yeah,
People
no.
didn't know what LeftPad was until that day.
Right, because a lot of big packages like I had the list somewhere.
Express probably.
Yeah. A lot of very important packages depended on LeftPad. So transitive dependency resolution failed and nothing worked. And this is kind of the problem our folks run into. And I had to do some workarounds, probably writing those 11 lines of code for
Finding them from a cache, but eventually they get the build out, they put it on the internet. But this is not the end of their troubles, right? This continues like that for them for a while.
It goes repeatedly. They fight fires.
Fire after fire, day after day, right? And that's typically how it starts. Until at some point, at least the teams and organizations that survive manage to get themselves to their next stage. And that's our Act 2. We call it the smoke alarm installers or reactive operations,
right.
reactive improvement.
We have the firefighters, they solve the problems as they arise. A lot of the problems arose continuously, time after time, the same problems, and they kind of fix them every time anew, with probably some kind of knowledge in minds of those three guys about how to solve a problem. But now, the setting is a little bit different.
Yeah. So let's see what happened with the company. So number one, we raised another round. Yay! More money.
Actually. Yeah.
Round A.
That's round A.
Right?
Yeah.
So we hired 26 developers. It's a big team now, right?
On top of that, we hired one developer with ops background.
Like the whole human being.
Yeah.
Like one. Like comes in a package.
Well, the success was the first customer actually raised some
awareness, and they've gotten up to about 100 customers. Not too bad. Not too bad for a startup like that.
For a startup, right. They kind of got tired in 3M.
Or being yelled directly by a customer, so they hired a support team.
To be yelled directly by customer. And the process evolved.
The process obviously had to evolve, right? Kanban with 26 engineers, you're probably running 3 Scrum teams.
It's 30, including the founder.
Yeah, it doesn't really work anymore, so they switched to Scrum. Seems to be appropriate for that stage.
Well, yeah, this is, who knows what exploratory testing is? Anyone?
One person, 2.
Yeah, 2.
3.
3, here we go, here we go, you will wake up here. Well,
it can be a fancy name for manual QA.
Exactly, and this is probably what they considered
It
it.
could be a methodology for properly testing your applications with things that you haven't covered.
Yeah. Fancy name for manual QA. Yep. Yep.
All right. Ops, well, naturally they have a guy, right? Or a gal.
I told them that there is no such thing as serverless, because serverless means
You just
use someone else's server.
No, you still have to deal with stuff.
And no ops actually does not exist at all, because there is always ops.
Right? They also realize that waking up everybody every night, every time emergency arises, doesn't work anymore, so they have this thing called the developer on call, right? Somebody carries...
The core developers rotate.
Used to be a pager, saying carries the pager is too old school now.
Yeah.
Right, somebody is responsible for being interrupted or being woken up in the middle of the night.
Right. And of course, solving the problem with logs, pretty easy.
Well, the ops guy showed up, goes, what is this, right? Everything should be in UTC, everything should be in one time zone, so at least they've solved the logs problem.
Yep. Tools, with the bigger team, with the more complicated process, tools evolve as well. So now they have, in addition to this issue tracker, some kind of a knowledge base. Could be Confluence, it could be wiki pages, on
Docs, whatever.
Google Docs or whatever. GitHub stays, Travis CI stays, that do the job just fine. JFrog Artifactory or something similar for caching both dependencies, so unpublished them again, and also caching what they roll out to production, so the rollback will be just take the previous artifact and put it back.
Right? They solved the logs problem by also getting a tool, because again, microservices, you can run around AWS or Google Cloud Console, but that's not fun. So you typically pick up a tool. In their case, they picked up Sumo Logic, but there's Logly, there is Splunk, right? A tool that aggregates the logs and allows you to run either queries, analytics. You can start alerting on that. Pretty useful set of tools.
Right. Who knows what Pingdom is? Pingdom? Anyone old enough to know what it is? Yeah.
So the most embarrassing thing that can happen to a SaaS company is when a customer calls and tells you that you have a problem and you don't know about. Right. So they decided that it's time to solve that.
And Pingdom is an amazingly simple tool that does one job. It checks the URL and reports when it's done.
It's like, are you up?
Yep, exactly.
Maybe the more advanced version does it from several places in the world. But,
Yeah, no, but at least now they covered from this call from the customer.
Hey guys, nothing works.
Nothing works.
Hopefully they know now before that, right? So they evolved a bit.
Okay, let's see how it looks like in phase 2.
Well, naturally, what is there to do when a startup raises a round of cash? You drink.
Right? They drink, so, as you can imagine, Friday night, everybody's drunk, and then customer calls. Well, now it's not that nothing works because
nothing alerted.
Because you remember they are protected from this kind of problem. It's something doesn't work.
Yeah, and now they have a developer on call.
So let's say this developer being told, the support first being told, we have a funny thing with American Express
We
transaction.
just run a big, customers are complaining, right, and Amex doesn't work.
Right, so MasterCard is just fine, Visa is just fine, Amex doesn't work. And the support guys, what do?
They call the developer on call?
They first check, at least for the sake of the process, they check in their knowledge base.
Nah, they call the developer on
And,
call.
oh well,
Come on, well,
later they claimed they checked the knowledge
I
base.
see.
And there's nothing there.
Well, what is the developer on call to do when he gets a call like that on Friday after drinking the whole evening?
Well, he goes to the code and tries.
Well, first he panics.
Oh, right.
You have to panic first, right?
Right. And then he goes to the code and actually discovers that he doesn't really touch this part because it was who wrote this?
Oh, Billy.
It was Billy.
Billy had a brilliant idea Friday night after partying, so he made some changes to the code, committed them. They passed all the tests.
Yeah, and
So they went straight to the production.
yeah, and it actually worked, right? The Amex transactions worked after he did this. All that there wasn't
So
no problems were there.
fortunately, because he has the knowledge base, he knows who is responsible for that area
Right.
of the code. He calls Billy.
Right. So he calls Billy, and Billy is like, that looks very familiar. I think I had this exception that you see now, and I fixed it.
Yeah.
And the Jira issue looks kind of funny.
Yeah,
It
it's
is
not.
closed. It is done but not closed.
Yeah.
Closed but not finished.
So I don't know. Maybe the code never made it to production.
This is weird.
So they look and look and look, and at some point they figure out, Billy, who was playing with American Express code, realizes that the issue is actually that the message queue is overflowing.
Right. So he bumps up the message queue.
And obviously you flash the existing messages out of the queue.
Well, we'll talk about that. And then the next morning, Monday morning, they do something new.
Yeah.
Happens in their second phase.
And this is something that happens when the team reaches this reactive improvement stage, right? They after the incident is done, after the fire is out, they sit down and figure out what happened. And most important thing, they figure out how to make sure it doesn't happen again, right? Hence the smoke alarm installing. Whether you correct the process, whether you install a new monitoring alert on a particular condition that you didn't realize existed before. And here's an example from one of the teams I used to manage before.
So what we actually have is we know how to prevent the same fire from happening again. Right, new ones will be there, but at least this one won't happen again.
So here's an example of a root cause analysis. That's something that the person who was on call is typically responsible for producing, right? You document some of your basic, like when did the issue start, when did the issue stop, how many hours. We protected the not so innocent in this case by removing some names and product names, right? But you can see there's a log of events.
How do you even gather that? Do you have this court secretary typing in the corner of the war room in their tiny
Yeah, the special keyboard?
Yeah. This is how.
No. Typically, what you do, and this log of events is important because under fire in the middle of the night, it's important to figure out when you do the analysis what was the actual sequence. A lot of teams use their favorite tools for collaboration, whether it's Slack, HipChat, or something similar, and have an incident channel. And that's where all the messages go, and that's where you go to extract your event log, right? And this is a raw, almost cut and paste from there.
No.
Right? Then you describe the symptoms, and that's important because those RCAs go into the knowledge base for subsequent developer on calls and other folks to figure out, hey, if something like this happened when you do the search on the knowledge base, maybe I can find what happened before so you don't end up in another Groundhog Day.
So for us, this will be American Express transaction fail with a certain exception.
Like queue overflow.
Yeah.
Right? So somebody searches next time on queue overflow, they may be able to find this, they will see that what happened, they will see what corrective actions were taken or not taken, right? Then you have normal description of what happened, right? In this case, if you guys want to read it, we figured out what exactly happened. There's a particular component. We applied the fix.
So this is kind of
Analysis, the actual analysis.
how do we investigate it the problem in the real life.
Yep.
Right? So here will be Billy looked in this code and then in that code and then he discovered this and that and etc.
Right. Then ideally, and it's not possible in all cases, you identify a root cause, right? And there are cases where you can't identify the root cause, where you follow up maybe, hey, you know what, we don't really know what happened, but here's the extra monitoring, extra logging, extra troubleshooting we're going to add to the system in order to make sure that we actually catch the root cause rather than the symptom of the issue, right?
And next time, maybe with this logging, we will be able to get to the root analysis when this happens. And in our case, the root cause was obviously
there's a defect, and absolutely, this is where the tracking comes in. A good RCA always will have some kind of action, right? Hence the smoke alarm installing, right? That is clearly documented, that is ideally cataloged somewhere in the backlog, so when the next developer on call 2 nights from now wakes up, they can find this RCA and they will see whether this was already done or not, for example, because some code may take some time to fix, some monitoring alerts may take some time to propagate or get instrumented, etc., right?
So in our example, that will be first flush the existing transactions from the queue because we need them anyhow, and then enlarge the queue. Right?
Yep.
Those are the 2 steps. And when enlarging the queue, the question is by how?
Well, 42.
42. 42 is a good number. And how Billy got to 42?
I think Billy looked at the sky, and it came upon him, because they had no better information to enlarge it to anyway.
Right.
So those retrospectives are key for this type of reactive improvement, right? And they're painful, especially early on when they get going, because you see things like the blame game, oh, it's the DBA, or it's the ops guys, or it's the security team who had an extra firewall rule.
So Billy is like an easy rolling guy. He has no problem saying, yeah, I fucked up. That's okay. I was just drunk. Well, remember that he is one of the founders, so
yes.
It's kind of easy for him. But the junior developers or engineers might start hiding information, right? Because, well, I messed with the DNS now, but I won't admit that I did it because they're going to fire me.
Yep. And that's important to create the atmosphere where those things, while painful, are productive, and everybody puts all the information on the table, because otherwise you'll never get to the root cause. And more importantly, in a lot of companies get to the stage of maturity, early on those incident reports are kind of rough. It takes 5 to 6 months, maybe a bit more depending on your team, to mature. But at some point, you're going to be at the position where you're going to start sharing them with the customer, right? And you go, really? Sharing them with the customer? That seems like not a good idea.
Yeah, well, no, you heard about it, right? That it's called post-mortem. In a lot of cases, it calls like accident investigations.
Incident report.
Yeah, right? you heard about them, like a lot. There are companies that do that. And the real question is, how much do you want to share
and that depends, right?
Is there a point in which you say, you know what, this is too catastrophical to admit?
So before we answer that question, I think that based on my experience, having worked at a variety of sizes of companies, it depends on the company's risk profile and sensitivity. I've been to the companies where before the root cause or incident report gets released to the customer, somebody from the legal team looks at it, right? Because there may be extra liability in there. But fundamentally, the way to think about what you want to tell the customer and what customers care about is, customers don't care about a particular incident in reality. Something breaks, right? All they really care about is what are you doing to make sure it doesn't happen again. And you don't need to share a lot of information, although some companies do, to assure the customer, right, that it doesn't happen again. Sometimes it's saying, hey, listen, we've noticed that we were not monitoring the queue sizes on our queues for American Express. We had a new threshold. We now have an alert. We have a developer on call. They'll get paged next time, so we will discover before you will, right? Sometimes that's enough. Sometimes companies go much further.
Right. And so back to the question of this tolerance of customers to the scale of the catastrophic event, you might think, as I thought, there is some limit.
Like, for example, in a SaaS product, right, the scariest thing you can do to your customers is destroy their data.
So the good news on the bad news, depends on how you look at it, probably good news are that this tolerance is almost
Infinite.
Who
Has
remembers
anybody seen this GitLab incident?
GitLab.com database incident, February 2017. Couple of hands? Okay.
In a nutshell, they managed to delete a bunch of data.
All right. Yeah. So yesterday we had a serious incident with one of the database. We lost 6 hours.
6 hours of data, right? Normally, if you don't do anything, for most companies, and we were watching this live. I remember I was back home, kind of following the news. This could be a kiss of death for a company.
Oh yeah, no, absolutely. We watched it and we discussed it. And
It's a play-by-play on Twitter.
right, and we're like, okay, they won't survive.
Like GitHub has them now. That's it.
6 hours of production data, no one will want to deal with that.
So here's what
First of all, how the RCA looks like.
Yeah. So this is theirs, and by the way, theirs is public. So let's skim through it.
Right. So yeah, this is what they did to recover. So someone deleted the production database. This happens. Like who of us didn't delete the production database?
I know I'm responsible for at least a couple.
So the real question is what happens next? And
Well, team member 1 is the key actor
yeah.
here.
So there's this guy, team member 1, and this guy actually deleted the database, and then he tries to recover.
Restore it, right? Of course, you have a knowledge base, you have a process for that.
Okay, regular backups. The team member 1 was not be able to figure out where they are stored. So there are backups somewhere, probably. No one knows where they are.
Well, but he did call team member 2, who discovered that those backups are only a few bytes in size.
This is something else, right? Team member 2 said that they don't work because the files are empty.
Don't despair. We have database dumps.
Absolutely. Database dumps didn't work because we run the dump tool with a wrong version, which didn't match the production database version, so no SQL dumps were made.
Okay. But we also have disk snapshots.
Right, of the production servers, but not the database servers.
Oh, okay. That's not going to work. We have synchronization.
Yeah, no, but that goes with the backup, so they're
Didn't
kind
work.
of lost. Replication, though, well, the replication procedure is super fragile, prone to error, relies on a handful of random shell script, and is badly documented.
So I suspect team member 1, team member 2 were doing this thing with the bag, panicking when they discovered that.
And
But they had another backup, S3.
right,
But it didn't work.
the bucket is empty.
Like this is like watching train wreck in slow motion. So in other words, none of their backups have worked.
Different replication and backup techniques. 5. So you watch that, and you go like, there is no way those guys are going to recover.
Right?
Team member 1 is going to be fired. They're going to lose all their paying customers, and they will be sold to the top bidder for a very reasonable price in a very
Short
near
time.
future.
Yep.
Well,
Surprisingly, thanks to their transparency, right? And it takes courage to be that transparent with their customers, right? A lot of companies on the internet send them cookies,
oh, absolutely.
money, congratulations.
Well, so before this whole accident, team member 1 was supposed to get a promotion, like scheduled one. He actually got it, right? And also he changed his description on Twitter, his one-line bio, to database removal specialist. Now, he's a very funny guy.
Now, while this is like watching disaster movie in slow motion, I think the important thing here is GitLab did not look at the symptom, i.e. a developer accidentally deleted something. Stuff happens, right? They looked at the root cause of what caused an ability for the system to recover, right? And they fixed that, and they were transparent about what they're going to do about it.
And no blame game happens not at the first RCA, because no one knows, right? So I'm going to admit that I did something. I don't really know how it will be accepted.
Right.
But after seeing team member 1 got this promotion after all this shitstorm, next time I will feel much more comfortable saying, yeah, I think I messed up the DNS files.
Right? And maybe the problem is we have no backup, or I couldn't roll back, right? Look for the root causes rather than the symptoms, and that's what characterizes the teams that find themselves at the stage of reactive improvement, right? Things happen, they look, they analyze, and they make sure it doesn't happen again. Like for me, when I was running SaaS products, the most embarrassing thing is going back to the customers and explaining why the same incident happened twice in a row.
Right.
Like I can explain the first time reasonably well.
Exactly. And the first time will be accepted because shit happens, but it shouldn't happen again.
All right.
So you might think that things are improving and getting better comparing to the first act, and this is how the Greek tragedy works. We're kind of getting better, and now everybody dies.
Everybody has to die. That's a Greek tragedy.
So third act is what do we call a perfect storm?
Well, let's see what happens to the company at this stage.
So now they raised more money.
Yay! And they've really grown. Another 74 developers, right?
So it's 100 people engineering team, R&D team.
5 guys with ops background. Like they're moving forward. And
the whole performance engineering.
Like again, another whole human body thinking about performance.
This is what they pay them for.
Yeah.
Amazing. Chief architect.
Ooh, this is typically the scary state. The chief architect shows up, and we'll talk a bit about that more. They have this new thing, customer success team.
Aren't they salespeople, customer success team?
No, this is a different team. So what they've realized, being 100 engineers, probably at this stage split across a couple sites, interruptions do happen. Interruptions happen day to day in the normal operations of the product, but interruptions are very costly for the development teams. So they've designated a small team of people, and different companies do it differently, to be interrupted so the rest of the team doesn't. I've seen teams that put people on customer success team for a sprint, maybe for a quarter. I've had engineers who actually didn't like writing like I had spectacularly senior software guys working on my teams who didn't like writing the long-term code. They were the firefighting kind, and they actually didn't want to leave the customer success team.
Why? Because it's playing the detective and trying to solve the crime. Well, they are the murderers also, but
sometimes.
Yeah.
Well, yeah, it gives you that endorphin rush immediately, right? And that happens day in, day out, right? So the important thing here is to have a team, whether it's one person, sometimes depending on the complexity of your software, maybe few people, they may be spread geographically, right? So people don't have to wake up, and they become the first line of defense with the support team, right? The support team interacts with them. If you have some permanent folks on this team, they tend to start building the relationships with the support team, so there's trust that is developing, right? And they also develop the skill of troubleshooting the system. This is also where we introduce this other concept we want to talk today is, as somebody who runs a number of engineering teams, I'm a big believer that pain is instructional.
Oh, yeah.
Nothing made me write better code than waking up at 2 a.m. on Friday lightly drunk, and instead of spending 15 minutes troubleshooting a piece of software, spending 2 hours because I forgot to put a line of log.
Yep.
Right? That kind of teaches you. So pain is instructional, and unfortunately you have to bring the pain to the source. Right? More often than not, those issues are created by developers.
So sadistic reasons aside, this also solves the problem of the subject matter expert not being on call. Right? You remember how the developer on call had no idea what happened with American Express because he never touched this part of the system? Customer success team will probably be diverse enough so they will have the subject matter expert from every area of the system on call at any given time.
All right. Then you've got legal. Big enough. Legal showed up.
In finance, they process credit cards, they have sensible client information. They should have this guy by now.
Well, they got one, and they also got the CFO. The VCs wanted them to have a CFO. Somebody has to watch over the money.
Exactly. It comes together usually.
The customer base has also grown. They're at about 1,000 now, right? They've grown 10 times. Pretty good.
Right. Let's talk about process.
Well, naturally, when you have 100 engineers, Scrum may or may no longer work for you.
I don't know how it can work. You have, 8 Scrum teams?
8 Scrum teams.
You work on the same project?
Probably with some dependencies between them. You have a chief architect who has a particular desires. The chief architect thinks of things like non-functional backlog. So ability to monitor, ability to troubleshoot, ability or certain requirements around performance. So they adopt
microservices that are all interconnected as well.
So they've decided that instead of inventing their own process. They went to a known framework. If you guys haven't heard of it, it's called Scaled Agile Framework. There are a couple competitors to that framework. And instead of inventing job descriptions for everybody, they went to the website and they just copied from them. And if you haven't seen, the SAFE has for you, I know, a very scary website.
My eyes bleed when I go to this website.
For me as a practitioner.
It's so much process. It's like you want to die.
Well, that's why you have the job you do. You decided process wasn't for you.
No,
but the beauty of SAFE is, number one, you can adopt it in layers. A lot of people think that process has to be adopted big bang, right? Realistically, the process is there to manage risk. And you have to tailor to your own team what types of risk you need to manage based on the product you're working on. And the bits of process you need to adopt, maybe because you're distributed, maybe you've seen some weaknesses in architecture, et cetera, et cetera. So I encourage you to go to their website. It's called scaledagilepFramework.org. Click at the diagram, click on every role. You can see what processes are meant for, what good looks like, and what to do, and most importantly, what not to do.
QA, you remember they had pretty good QA coverage, including the unit tests and integration tests, and some exploratory QA to cover the pieces which were missing.
And every team is responsible for their microservice, but the question becomes, who looks at the system as the whole, right? Who sets up the environments where you can spin up a system and test it under certain conditions, right? And that's where you have folks like a system testing team emerge. Their job is not to be the central QA. They're the best practices people and the tools and infrastructure people that help the rest of the team do their testing at scale, right? I'll give you an example. One of the products I was responsible for was an APM system. Well, in order to test an application performance monitoring system, number one, you have to deploy a lot of load in a lot of environments. You have to manage all of those environments. You actually have to write software to instrument so you can test your software with particular performance issue. Somebody has to do all of that, right? And this is best done centrally because those are the assets that are needed by a variety of different Scrum teams. So that's when you see this type of centralization of system testing.
Okay. Now this is where you should leave the room in anger.
I would say storm. Storm out of the room.
Yeah, because we are talking about DevOps, and DevOps means we don't have ops teams.
We don't have us and them anymore.
Right? And here's something interesting emerges. Now, what we see today in the market are two different ways to implement DevOps. First is by the book. Everybody do DevOps. Engineers are responsible for taking their code to production. Those are brilliant people that kind of learned the other part of the house, and they know exactly how Mesos, Kubernetes, Docker, Compose.
Oh, for example, how to
Chef
turn on
and Puppet, and
turn on Java 8 on Google App Engine.
Right, and how to turn Java 8 on Google App Engine. And they do DevOps. They do everything. And then there are guys who, formerly known as Ops, now do only a very tiny piece of it, which is site reliability, taking care of site reliability. Right, the engineers won't take care of site reliability. This is not their job, but there are a couple of special people that only do that. They don't do ops anymore. This is the classical approach, which works in very, very specific kind of companies, and if we're talking about big ones, you probably can count them on two hands. Right, it's Google, it's Netflix.
A lot of consumer companies certainly adopt that type of approach. In contrast, guys like Box have a blend.
Right. So the other type of implementation, I would say for the rest of us, that have different kinds of engineers. Some do care about this stuff. Some care about it less and say, okay, we are okay with taking our code to production, but we need an infrastructure that we won't particularly be knowledgeable about. All we need is to be able to use it. Right? So if someone will set up the infrastructure and teach us how to do it, we are okay with DevOps. We will take ourselves to production. We won't blame other people. We won't give it away to the ops team, but we don't want to deal with this infrastructure. And this is where those ops teams, and this is the majority of the market, the majority of the industry, this is where those X op teams, and now there are different names for it. It could be DevOps service team, it could be DevOps enabler. This is where they come, right? So it's usually a bunch of X operations people with the operation background that lay down the foundation for this DevOps process for the rest of the company, right? They set up Docker with Kubernetes and Mesosphere and write those Ansible recipes and chef cookbooks
And set up the tool chain, the continuous testing, continuous delivery, the code analysis, right? They almost becomes the tools team as well.
exactly. And then they evangelize those tools to the rest of the engineers, right? They come and they sit with them and they say, this is how you do it now, this is what you need to do, and this is how your code ends up in production, and this is where you check that it actually was successful, and if not, this is what you do, etc.
Much like what we talked about in system testing, right? Centralizing some expertise and knowledge that are needed by everybody. This is type of centralization of expertise and knowledge that is needed by every single team.
So there are people that will claim that this is not the purest DevOps out there. Maybe they're right, but considering that you have a diverse team of engineers, that not all of them do really care about the bits and bytes of how you write an Ansible role, this is a very valid approach that, as I mentioned, most of the industry are taking. This is what you had both in CA and in Oracle.
And at Taleo.
And at Taleo, and this is what we see with majority of our customers and users.
Yeah.
With very rare exceptions.
So the next thing that shows up at this stage is an escalation pass, well-documented escalation pass that says if the problem happens and you can't resolve it for 15 minutes, well, call the subject matter expert. And there's a knowledge base now. You have the list of subject matter experts for a particular area of the system. You also typically have a manager on call, somebody a bit more senior than the individual engineer who's on call, who you can wake up to get some help marshaling resources, maybe communicating with external teams such as support, right? That's their job. The most interesting thing about those escalation passes, the good ones define progressive escalation through the entire organization all the way to the CEO.
Okay, so there is a couple of good reasons why you want to involve.
Yeah, why? Why?
So I would say the first reason is sometimes the problems are so big that someone needs to play some golf.
Somebody needs to get on a private jet, go to a golf course, play a game.
And play some golf. So that's one of the reasons.
But the second reason, and I've seen it time and time again, it's kind of magical how you set up those escalation thresholds. And let's say if the problem hasn't been resolved for 5 hours, so you call the CEO in the middle of the night. It's amazing how many problems get resolved in less than 5 hours because of that, right? It's a bit of a psychological trick. Certain people on the escalation pass are there, so you never have to call them.
And this goes back to pain is instructional, and this is, I would say, threat is instructional.
All right, let's see what else.
Yeah, regulation stuff like SOC 2.
Yeah, those guys gotten big enough, right? PCI, DSS, SOC 2. Fortunately, they don't do medical. There's no HIPAA. But they may be now in Europe, and there's this lovely thing coming called GDPR for privacy, right? And SOC 2, a lot of people wonder, like, how can you do...
So the problem with SOC 2 that a lot of things in SOC 2 directly contradict with DevOps.
Oh, do they?
So, for example, one of the rules that you
Principles
that are in SOC 2 is that the ones who write the code cannot be the ones who take it to production.
Which is typically interpreted means no developer shall ever get access to the production environment, period.
And you're like, what?
Normally said in that voice, exactly.
This is DevOps. This is about developers having access to product environment to ship their software.
Well, here's the thing that people don't realize about SOC and other standards. Specifically, SOC is about declaring the controls you're going to have and how you're going to audit yourself on those controls. SOC doesn't say the developers can access to production. SOC recommends having separation of concerns, and in some companies that can be achieved by having a tool chain that is stable and controlled by the operations team that gives the developer certain types of access. For example, Loggly, Sumo Logic, Splunk can be configured to give developers access to production logs, but only subset of them, or with masking, or with filtering, right? Nobody said you can't. Somebody said it has to be controlled. You have to be able to explain how are you controlling it, how are you making sure the controls are in place, and why are they needed for you to perform your business. A lot of companies, for example, for the developers on calls, have tools that when you rotate in and out, your access goes away, right? It makes sense. Like when you're not on call, you shouldn't have to access production, right? And it's easy to set up, and a lot of people can achieve those types of compliance with those audit standards by doing some lightweight processes to ensure the compliance while allowing people to do their job. Right? Because nobody would want to go on call. I wouldn't want to go on call if every time I needed a piece of log, I had to call somebody in operations. Never happens, right? Can you please log into that server that I don't have access to and give me that log? Oh, wait, no, it's not that log. Hold on a second. I'll call you back in 15 minutes. I need this log now.
And it will be sent to you by email in clear text.
Ideally. Ideally. That's how they typically show up, right? And because they have a chief architect now, somebody has to worry about the system overall. So at this scale, you tend to start thinking about a proper product backlog, and you have a conversation with your product management about allocating investment to that backlog called the non-functional backlog. And things that go into the non-functional backlog are things like monitoring requirements, scale requirements, continuous refactoring requirements. Sometimes you have to do vulnerability scanning, and you find that the old version of the library was vulnerable, like somebody didn't do it Equifax, and you have to go and actually update it, right? Somebody has to allocate time for that. It doesn't happen magically. The job for the product manager for this typically becomes a chief architect, right?
Right. And of course, we have tools that involve to support all that. Our backlog tracking and issue tracking and our knowledge-based state, of course, source control. Configuration management is a new piece of software right here, and that's because we have a lot of environments now to configure, right? So stuff
with a lot of services.
With a lot of services, all of them need to be configured in a centralized way. So there are a lot of tools in this regard. Travis CI is still good. JFrog Factory, Beanstalk Sumo and proper APM now instead of these funny pingdoms.
Remember that 42 problem?
Yep.
Right? So at some point you realize that just monitoring yourself from outside is not good enough, right? You probably want a much finer grain level of monitoring. You want to monitor individual business transactions. So when somebody from support calls you, you want to hear something like, hey, the login transaction on our mobile app is exceeding 5 seconds, right? Not, hey, customers are complaining. Slow. It's slow, right? You need tools like that. You also need to have some historical data in order to understand what's the right set? What's the right level for that queue?
So this 42 is actually, is it enough? Is it not enough? Maybe it's too much. Maybe we allocated resources that we will never need.
And we're paying for them.
Right?
Right. Now, the next most important thing that happens to the company at this stage.
Right. Yeah, so Billy got promoted. And
Billy is now head of engineering.
Yeah, it's now head of engineering. And
well, because, he was writing those late Friday night commits, and the developers didn't want him there anymore.
Right, and by the quality of the code they prepared, you see that they don't particularly like Billy in the company, for the obvious reasons.
So let's see what happens.
Right.
So number one, when you remember, you should know by now, when you raise a new round of funding, what do? You drink.
Right. So you remember that, and you know what? Nothing happened. Nothing bad happens on Friday night.
No. Like they're big enough, things are a bit more stable now.
Yeah, things work. But on Monday morning, Billy
gets a call. He gets a call. Remember they hired a head of legal? So those guys have their conferences too. Like we have the development conferences and ops conferences. They have the legal conferences where
she went to this conference and she came
where they discuss like fine subjects like compliance with open source licensing and LGPL 2.2H. Actual title.
And what are the differences between LGPL and AGPL?
So naturally, the head of legal comes to Billy and she asks, hey, Billy, like, do we have any of those types of open source licenses in our code?
Yeah, like GPL or other open source viral licenses.
So what are you to do when somebody asks you that question?
Billy does the natural reaction that Billy does every time people ask them questions.
And
but you know, then you realize, well, I'm the boss now.
I have 100 engineers, so we charge.
So Billy sends all his engineers to dig through
every single license, every single POM file in Java, every single NPM file in Node to see what happens, right?
Now, the good news are they have centralized dependency management, they have Artifactory, so at least all the dependencies are in one place.
But it still works.
It's tons of work because they need to parse everything. And it couldn't be in POM.xml, it couldn't be in package.json for NPM, it could be in NuSpec for NuGet, it could be its source code in the header of the source code, and it could be a separate .license file.
Or it could be not there.
Or it could be none of them.
Because somebody cut and paste from Stack Overflow.
Exactly.
Never happens.
So, and let's say they do find some library which is in compliance with what the legal says. Now what?
Now you remediate.
The release is still tomorrow.
Yeah.
And now you are dependent on some package, and let's say it's more significant than leftpad, that you need to rewrite a lot of code to find an alternative.
Yeah.
Not fun.
The following day, Billy gets a call from the CFO.
And now they have CFO, and the job of the CFO is building a budget. So CFO asks Billy, do you know, can you estimate how much we're going to spend on our cloud services next year?
Well, what's Billy's first reaction? But then he goes, of course I do. I'm the head of engineering. Don't despair. Goes back into his office, closes the door, brings the chief architect, and then they look at the sky.
42.
42. Why? Well, for two reasons. Number one, the CFO doesn't know any better. Number two, no CFO ever refused money for production services when you get more customers. So that's an easy bet to make. Number three, he doesn't have any data, right? He still doesn't have any data to proactively project his future.
The next morning.
It's been a horrible week. The next morning.
You know this guy?
Yeah, Baruch, as I told you, if we have to explain the meme, it's not a good meme.
I explained every meme in this talk so far, and it was great. So this guy, if you never watched a YouTube video in your life, is Mr. Blendtech and his hilarious show, Will It Blend?
They blend everything. Like he blended
iPad, iPhones,
a broom. I've seen him blend a broom.
like all you can think about, those guys blend. And
But in our case, the head of sales comes to Billy.
right,
And says, hey, Billy, we have this giant customer.
prospect.
Prospect. You're
Yep,
head
yep.
of sales. They're about to sign up, but they want to know whether we can scale to their demands.
Yeah, and then they have some huge scale, and they ask Billy.
So, Billy, what say you?
So Billy does that, but then he actually realized that the best,
He used to code.
right,
It's his system.
and the best answer he can get to this question is from the people who actually write the code. So he goes to his developers and asks.
He decided not to answer it himself. He brings the team along for the ride.
And then he asks the guys, "Will it scale?" And they're like, "Sure, it will scale. Absolutely,
Of course. We wrote that.
it's great. It will scale." How do they know, by the way?
Well, they kind of had to guess.
Yeah.
Well, maybe that whole human of a performance engineer had some opinion, but
Yeah. Well, so you remember we are in Act 3 of Greek tragedy, and let me tell you, it didn't scale.
everybody
died.
has to die.
Yeah, everybody died.
But don't despair. We're in North America. Every movie has a
From California.
yes. Every movie has a happy ending.
We know about that. So we will attach a happy ending to our Greek tragedy.
And
we
we'll
will
call it
break all the rules.
We'll call it Smokey Bear, the proactive improvement stage of DevOps.
So we're going to talk about the process and the tools, regardless of the composition of the team can stay the same. And this is how we save the day for Billy.
Right. We start doing proactive performance and scalability testing. Now, a lot of people think that this is the panacea for scale and performance, but I've never seen a lab test leave itself in production. That's where tools like APM come in, right? Leveraging your data for continuous improvement and looking at that data and looking at the metrics periodically, we'll talk a bit about that, gives you a reasonable degree of belief that you can actually get ahead of the customer base.
Right. So there are trends that can be monitored.
Yep.
Now, the problem with license and consistent with security is actually...
It's a bit top of mind for most of us
right.
in the US
and
right now.
And that can be easily solved, right?
Apache struts too.
Right. There are tools that will alert the right people when a developer adds struts to their dependency management. It doesn't have to end up with breach of 300 million.
245. 247 and a half now.
I think they raised it once more. Right, so it doesn't have to be that way. You can monitor the dependencies that go into the system and alert for any kind of information. Obviously licensing, so we won't use any vile open source licenses that will make our software open source, whether
like Linksys,
right?
Did once.
Yep, and security as the other, but also performance, getting back to performance. If I can identify that I have a slow component somewhere in my system, there are tools that will alert that this component is used in other places as well, and I can tackle that.
So we talked a bit about proactive performance testing, but there's also reactive performance testing. And typically at the stage of maturity, you see companies looking at the performance metrics on a periodic basis, whether it's weekly, monthly, bi-weekly, whatever is appropriate for your team. You typically have some kind of flash report, right, that gets disseminated once a week with the key metrics, whether it's the number of transactions, whether it's the average response time, what are your top 10 slowest performing transactions, et cetera, et cetera. The key thing about this, and we talk about one of our favorite tools for metrics, Excel, not to use Excel for something like this, because this has to be automated, because otherwise it will never be done. So it cannot be, hey, dear program manager Kathy, can you please go and pull this flash report for us once a week because we want to look at it, right? You want to start pulling your metrics using tooling. You want to identify your bottlenecks, and this is what starts feeding your non-functional backlog, right? Hey, we're seeing that this is our top 10 performing transaction in terms of lack of performance. Why don't we put a couple story points or whatever appropriate number of story points for you on a backlog for somebody to go look at it, right, before it becomes an incident?
And yeah, the non-functional backlog that we spoke about actually should be transformed to a more call to action, concrete terms.
Yeah, and typically that materializes as a non-functional definition of done. And you'll see that non-functional definition of done materialize in something like, hey, if you want to create a new microservice, well, it has to provide a monitoring endpoint. It has to log to a standard logging system. Ideally, it has to do security like the rest of us. It has to be built on the same CI, et cetera, whatever is appropriate for you. And ideally, it's not just a document on the wiki page that nobody reads. Ideally, your team went and extracted some of those common non-functional concerns into an inheritable component. So if you start writing a new microservice, you can say, hey, inherit from a new microservice could be a base Docker container, could be a set of Java classes, and I'm just going to focus on my business logic, right? And then your ops team and the rest of the team has a uniform way of dealing with your services and your components. And those processes come in the way of tools. So, for example, JFrog X-Ray for managing the dependencies and scanning them, recursively for security, license, performance issues. The fancy buzzword for that nowadays is software composition analysis, like what's inside.
Exactly. So using a tool like that, we can actually go and find these struts in any level depth of any component. Stuff like BlazeMeter or other cloud stress tools.
Right. The problem with load generation for proactive load testing, it's hard, right? Spinning up 10,000 concurrent users of any mean requires infrastructure, requires timing, requires planning. So a lot of the folks are starting to move to on-demand services like BlazeMeter to do their load generation.
And then those guys generate a lot of load on your system. Right. This is what they do.
The other thing, we talked about system testing and testing your system as a whole, but sometimes it's impossible. You may be integrating with a third party that doesn't give you a test system, right? So this is where a class of tools called service virtualization comes in. If you guys are familiar with mock objects for code, think of service virtualization as mock objects for third-party APIs. Right, where you can prescript the set of API calls that will happen, you can prescript the results, and you can still conduct your entire system testing, right, without being dependent on your third parties. And again, goes back to the responsibilities of a system test team. Somebody has to figure out how to use a tool like that, how to deploy a tool like that, how to manage a tool like that. So that's the responsibility of those centralized small teams to figure out how to use those common tools.
Now let's see a couple of examples of how those processes and tools actually solve the problems that kind of killed Billy. You remember how he sent the developers to look for licenses, and we mentioned JFrog X-Ray as a solution. And here is an example. That's a screenshot of X-Ray, which was alerting on some jar file which have an unappropriate license inside our application war file, inside the tar.gz, inside the Debian package, inside some Docker layer, inside the Docker image. Right, and this is because
that's a lot of insight.
Yeah, and this is because a Docker image was added to the system. We know how to go inside and find this guy, which have an appropriate license or a security issue. Now, how do we solve this problem of budget planning with Billy had to just come up with a random number? Well, and we're going to show you a very complicated, very expensive, and very
sophisticated
tool, Microsoft Excel.
Right? Yeah, you know, we talked about non-functional backlog, but the question becomes, how do you get it on your development effort, right? So not a lot of teams that I've worked with had this, but the best way I found to do this is like, take everything you're working on out of your backlog management system and aggregate it into something like this, a simple pie chart. As a head of engineering, I would typically get together with a head of product management and say, hey, listen, as much as I may not enjoy brushing my teeth every morning, I still have to. Otherwise, there's consequences every time I go to a dentist, and they're expensive. Much like with our own body, you have to be proactive with software as well. The question becomes how much time and effort we're willing to allocate, right? And you start looking at your investments and your backlog as a proactive investment, as if you were managing your own retirement portfolio, right? You want a certain number of some amount of money in high-risk investment, some amount of money in low-risk investment. Similarly here, and this is from an actual product I managed, right? We've allocated certain investments, and the other thing you typically find when you do it for the first time, you find how thinly the team is spread. You have those tiny little slices of like 1% or 2% of investment, right?
And there are also very interesting surprises. So
yeah, you're like, wait, are we working on this?
I bet your goal for this sprint was big feature 8.
Yes.
But most of the money, time, and effort was actually spent on keeping the lights on.
Right. And this is a multi-$100 million product, and actually 34% in keeping the lights on, which is patching, bug fixing, minor improvements. It's not a bad investment, but it has to be clear.
Exactly, because if you think that you work on big feature A, news, you know.
Right. And then you allocate things for, like, for example, the first blue slice, improving engineering velocity. We decided that, you know, we're not moving fast enough. We identified a number of initiatives, but we couldn't fix them all, or we couldn't execute on them all. But we decided about 5 to 6% of investment we're going to put proactively towards improving ourselves, right? And if you want to have proactive improvement, it doesn't happen without allocating time and money for that.
Right. You cannot just say to developers, okay, just make sure you refactor some stuff on your free time. You know, artificial intelligence also can help us when we plan for the future. So that's exactly.
Actually, can you go back one slide? One other item I wanted to mention that a lot of people forget about. We talked about the chief architect. There's another investment, typically 5 to 7%, and it's called uncategorized research for future releases. Right? It's another thing that allows the team to kind of break the deadly cycle of never getting out of the
bug fixes
and other places. You don't start thinking ahead of time. So if you want to start, you know, being proactive about things, you also start allocating capacity for initiatives that you may not be working in the next program increment. So not next 3 months, but the next 6 to 12 months. So you can do some research. You can figure out what frameworks are appropriate. Hey, if we wanted to do this giant refactoring and replace our search engine A with search engine B, how much is it going to cost? You're much better off allocating time to that proactively in both development and operations, because you're going to instrument, roll out, learn how to operate, right, and select the right one, than starting that development and then realizing that it's going to take 3 times more than you thought it would. Yep. Right? So that's another key thing you would see emerge when you go into proactive improvement.
So yeah, and as I mentioned, tools are getting smarter. Artificial intelligence can now kind of project some of the cost that you will have. That's again a screenshot from another tool of JFrog called Mission Control that can kind of try and guess how many storage you will need next year, so it will come with a better answer to your CFO. Now, how do we solve this problem? How do we solve really the problem of
Quality.
Now, I have a question for you. What is the best way to measure quality of the product?
If you were a customer, how would you?
No, not even a customer, for everybody, for Billy as well.
Okay.
What is the best way to know the quality of the product? Satisfaction of the customers. Well, we have a winner.
Yeah.
Take a t-shirt, Mike.
How does it typically manifest to the development team?
How do you measure satisfaction of customers?
A file defect sometimes, I think.
Right. So here is an image, again, a report built by this amazing and complicated and inaccessible tool of Microsoft Excel that breaks down the defects filed by customer by severity. Now, let's look at it for a second. 65% are severity 1 and severity 2. So I have a question for you. What do you think about the quality of this product? Is it good?
What's the reaction?
Not so much. They are just ashamed of you because they know it was your product.
It actually happens to be a product I was asked to help the engineering team improve. And then we started looking at data.
Right. And I would say that this is a great starter for a very intense blame
game with the support and with head of support.
Within the support and R&D.
And quite frankly, my first conversation with head of support before I had this type of data was, you know what? We're getting a lot of Sev 1s, Sev 2s. We have a lot of customer satisfaction problems. And by the way, every time the support team has to hand off an issue to development, our MTTR, mean time to resolve, goes probably up by a day, right? Because there's a transition. By the time somebody looks at the queue, by the time somebody answers, may not be in the same time zone. Didn't look too good. But at this stage of your DevOps scaling, data is the king, and having the right data and having the data with the right granularity becomes extremely important.
So let's add to this data, which is straightforward. This is what you measure.
So before we did that,
when we want to see if your product is good or not, and whether you have to hit Billy hard for delivering crappy code, this is what you do.
As a very irrational head of engineering, I went to my team and said, "Thou shall make sure that when you close the bug, you put the reason." Right? Because in this particular team, it was loose. It took us a while to get that data. You know, sometimes we may seem like we're making irrational asks of the team as heads of engineering, but in this case, when you go to the next slide, after we did that for a while and we look at the same data by resolution, you would see that only 19% of those defects that came to the development team resulted in an actual code fix, right? And about 52.3% on average were resolved by providing some kind of information to support.
Now, this is amazing. You look at exactly the same defects, exactly the same team, and exactly the same product. You just added more information, and you have a completely different picture.
Now,
suddenly, it's not the R&D team to blame.
Actually, suddenly it's nobody to blame, right? The conversation I was able to have with the head of support next was, hey, listen, this is the data. Let's agree that this is the data, and let's not argue about it, right? Let's agree that data is accurate. Once we've gone through that, we're starting looking at the actual root cause. It's not that support sucks, that maybe the documentation is not clear enough. Maybe we didn't do a good job training the support team. Maybe we don't have enough logs for them to troubleshoot that they can understand, and that's why they need the engineers. We worked with the head of support. I said, listen, if we need training, I'll send my engineers. Like, it's my own time, my engineering capacity you're burning with those questions. I will contribute engineering time. Let's figure out what to do. The key here is if you want to have any kind of proactive improvement, you need the right data.
Right. So data is super critical. And with that, let's jump to some conclusions. What everything means?
Only one person knew when we wrote this talk. It happened to be Baruch's wife, but she has a degree in literature and theater.
Yeah.
So if she didn't know, that would be a problem.
So that is the moral of the story. And we have a couple of points here just to remind you. First of all, scale is a scale.
So we talked about 3 key stages for scaling your process, right? Every team that I've been for, no matter how mature and how experienced the folks are, it typically start in firefighting, right? Because those things tend to take time to build up.
And you know what? The first starting with firefighting is fair enough, because you need to have just enough process in every step to keep being productive.
Right. The process there is to mitigate risks. It's not to slow you down or introduce process for the sake of process.
Right. So if you land safe now on 3 people engineering team,
they will never produce anything.
exactly.
Simple as that. So don't despair as well, because if you don't find yourself in proactive improvement as a team, when we worked on this as a study at CA, we only found that about 8% of the teams reach the stage and leave the reactive improvement, like the smoke alarm installing stage, and go to proactive improvement. Majority of the teams were surveyed, and we looked at companies, very large, Fortune 100 companies and much smaller companies. Majority of the teams find themselves in this reactive improvement stage for one simple reason. It takes a lot of time to put the right tool chain and the right set of alerts and processes and metrics in place so you can be proactive. And you cannot spend all of your time doing that either, because if you do that, you're not building any product. So most of the teams find themselves in reactive improvement. It's how you do reactive improvement well that will make you successful and will, over time, hopefully allow you to move to proactive improvement.
And as we mentioned throughout this talk today, all 3 of the aspects, people, process, and people, have changed.
And change is hard.
And change is hard. So the 2 of the biggest principles that we spoke today is, first, you build it your own, right? It goes all the way to taking responsibility for your code that need to go to production with help of others, and all the way to take responsibility for your code when you do the RCA analysis.
And of course, the second one, which is my favorite one, is pain is instructional, right? You will never get yourself out of the firefighting if you don't bring the pain to the source. If you isolate the people that create the problem from the people who are responsible for waking up in the middle of the night to fix the problem, you will never get better.
So with that, just to remind you about the links. So I'm Baruch.
I'm at Igolnik.
Yeah,
Oh, this is.
yeah,
you took me off, huh?
Yeah, I took you off. Yeah. It's Leonid Igolnik. And JFrog.com/show-notes is where you go. Hopefully starting tomorrow morning to get the video, the slides, all the links, provide the feedback, and participate in a small raffle. With that, thank you very much. Thank you.
Questions?
So if you have any questions, we're here all week, as they say.
Well, I'm on the plane at 7 a.m. tomorrow, so. Oh God, that's going to be fun.
I invite you all to come back tomorrow for more, even more fun, because we're going to have Java puzzlers tomorrow. So if any of you work with Java and want to realize that they have no idea, there's the place.
What the language or the JVM does, yeah.
Yeah, that's the place to be tomorrow. But otherwise, thank you very much. Any questions? Yeah.
Yeah, you have a QA function there. So in your view, QA is just amount of work that needs to be done, or you actually see it as a separate role?
So,
Just repeat the question.
yeah, so the question was, when you look at the QA function, is it amount of work that just needs to be done, or is it a separate role? I think the answer, well, as a good consultant, my answer will be first, it depends, because it is situational. But I'm a big believer that quality should be a responsibility for everybody in the team. It goes back to the principles of you build it, you...
QA in the name DevOps.
Yep, that doesn't exist. You build it, you own it. The problem is, like with a lot of those vertical functions, there's a degree of specialization and understanding methodologies, right? Quality assurance has a lot of science behind it. There's a variety of types of testing you can do, and somebody has to educate the team on best practices, enable them on best practices, and sometimes, depending on the scale of the system, support them with the environments and tools. So I'm a big believer that as you scale, at a certain point, a separate function focused on system testing should emerge. Those folks, much like separate function in DevOps, if we're thinking about this mythical startup, emerges into its own function where you have the right degree of specialization, because you have people with deep knowledge in a particular domain or particular set of tools, so you don't have to wander over the internet, figure out how you're going to be using Selenium, WebDriver, or other technology of choice. But I think in the teams I've seen successful, quality is top of mind for everybody. Everybody is responsible for writing tests. Ideally, the system tests team provides you with enough frameworks so those tests can be automated. But I do believe that in certain types of systems, there's room for exploratory testing as well, right? There are types of systems, like my last big product prior to security was APM. There's no manual testing to be done there, right? It's a profiler that runs on production. There's not much to test there automatically. Everything has to be stimulated, right? It also will depend on the types of engineers you staff your testing function with. And I also believe that on every Scrum team, like Scrum teams have core teams and observers, like the docs people come to the Scrum, the support team ideally comes to the Scrums. You also should have within the Scrum team somebody with a deeper understanding of testing and testing methodologies than the rest of the team, like you would have somebody with deeper understanding of performance or a particular framework, right? So that would be my view.
And that's exactly as what we discussed with DevOps, right? Everybody do DevOps. Everybody do QA. Someone needs to set up the tools, to know the methodology, to set up the tools, and to educate the rest of them how to do that correctly. It's exactly the same.
Cool. What else was there?
You were talking about increasing granularity to incidents and stuff.
Yep.
Is there a particular best practice for that?
So the question was, when we were talking about introducing granularity of data, in our case it was defects, are there any best practices? So at a minimal, when it comes from a development perspective, you want to understand where the time goes, right? It goes back to that pie chart. And a giant slice of a pie chart on where you're spending your time, on average, I've never seen it, I've seen it, I don't think I've ever seen it less than 20%, it's keeping the lights on, right? 20 to 30, and sometimes I've seen it as high as 50% is a big slice of investment. And if you don't have further granularity, you can't understand what you're spending my time on. So for me, granularity is required where I want to double click on the data and understand it further, right? And it goes back to much like introducing extra process for the sake of process doesn't work. But there are some best practices. For example, on a defect, you probably should know a component, so you can do some basic analysis for trends by component. You probably want to do the same for the incident. You want to do it for a root cause, and you want to do it for a resolution type, right?
So for here and here is where, so all those are obvious, the components and the resolution.
You'll be surprised how not obvious they can
Well,
be.
no, but I mean, this makes sense. But now we come to the resolution time, and this is where, in my experience, the most opposition you will get.
Yeah.
Because people will claim that they will fix it faster than logging in all those tiny fields in their Jira or whatever they are logging to. And you know what? They might have a point.
Except that we won't be spending the time on the right things, right? And that's my experience. It is sometimes painful, and the job of the tools team or the head of engineering is to find the tools that don't really interfere with the developer. But like we all have jobs to do, and one of those is to get the data, because that data helps us invest. Like for example, if you don't log the component or you don't log the trend for the incident, I can go back and look at the investment and say, you know what, guys? You're right. This component needs proactive improvement. Or I cannot go to head of product management and say, you know what? My last head of product management was Kathy. Kathy, we're looking at this component. This is the customer implication. Here's the data. And again, you've seen through this talk, data is the key here that supports my recommendation to invest more, right? And that's why quite often, and not every head of engineering does a good job explaining why certain data is needed. But ideally, that data is not there for the sake of collecting it. It's there so it can be acted on. And there are some fundamental best practices: root cause, resolution, time to resolve. So you can do some basic metrics. The rest is situational based on the needs of the team in order to answer those types of questions. Are we working on the right things? What's our worst component, right? What's our best component? What's our coverage? Those are the basic things that I think are well-known best practices. The rest is situational.
Just a couple additional announcements. In addition to the public talk tomorrow,
2 talks.
For the price of one. Free.
So, 430 tomorrow is a good sign for that. Number two is, for those of you who don't work at BNY Mellon,